Guys, welcome back to Chemistry TV. Now we are still on our JAMB chemistry class. Our focus is going to be chemical equilibrium. On that chemical equilibrium, our main point of focus is going to be change in pressure and volume. How does change in pressure and volume affect the equilibrium position? Now you have to see a lot of questions when it comes to this type of question. If you look at this one here, which of the following equilibrium is shifted to the right as a result of an increase in pressure? Now you see this one here. So by the end of this video here, I'm going to walk you through step by step on how you can answer questions like this. I will answer about 5 to 6 questions on this change in pressure and volume. Then we have to look at what past questions you get. So this is a score video. I've done the first video, on what chemical equilibrium. Please, if you have not watched that video on chemical equilibrium, it's very important you check out that video, because in that video I explain the concept of chemical equilibrium. I explain what's called dynamic equilibrium, how to write equilibrium constant expression, because you already see questions like that in the exam. How to write equilibrium constant expression. Then how does change in concentration affect the equilibrium position? When you increase the concentration of a reaction, the reactant will really shift to. Then I also explain how does change in temperature affect the equilibrium position. These are things you must know, master very well, in order for you to be able to answer specific questions in this video. And we are going to look at those type of questions in this class. Do you understand? So make sure you have your pen, your notebook, and your calculator, and take down every single thing. If you have not subscribed, please try to get to 4,000 subscribers in the next few weeks. Please help us to get to that 4,000 subscribers by liking, commenting, and sharing this video. And do you understand? This will boost it to other persons who are looking for this type of content. So let's get into it. Change in pressure and volume. Now, what do you understand by change in pressure and volume? Now, remember, according to Boyle's law, an increase in pressure will cause decrease in volume. So Boyle's law states that the volume of fixed mass of gas is inverse proportional to what? To its pressure, provided temperature is kept constant. So what you want to understand here is that an increase in pressure equals decrease in what? In volume. Very important here. An increase in pressure equals what? Decrease what? In volume. So when we talk about change in pressure and volume, they go together. Do you understand? So whenever I see an increase in pressure, it's also the same that what? Decrease what? In volume. Do you understand? Now, if you also talk about a decrease in pressure equals increase in what? In volume. These are key things you need to understand here. You get. Now, another thing I want to understand here is that change in pressure and volume affects only gases. So note, change in pressure and volume affect what? Only what? Gases. Very important. Affect only what? Gases. So these are key things you need to know when it comes to what? Pressure and what? Volume. So if it's solid, liquid, or aqueous, it does not affect. It only affects what? Gaseous what? States. You understand? Another thing you want to understand here is that, okay, so how does an increase in volume affect the equilibrium position, and how does what? An decreased volume affect what? The equilibrium position. How do you know that? So this is where I would explain to you. Look at something here. So there are some key things to understand here. When you have some question under this here, there are some key things you need to put in your mind. Do you understand? That will enable you to what? Answer this question straight. So the first one is this. An increase in pressure. Remember, when I talk about increase in pressure, indirectly I'm talking about what? Decrease in what? Volume. So an increase in pressure will shift the equilibrium sign to the side with fewer moles of gases. Now let me write here. An increase in pressure, you understand that what? Decrease in what? In volume. right? We move the equilibrium. We move the equilibrium position to the sides with fewer moles of what? Gases. Very important here. So now, whenever you increase pressure, pay close attention here. Whenever you increase pressure, you also talk about decrease. You also talk about what? Decrease in volume, right? So an increase in pressure will cause the reaction to move to the side with what? Fewer moles of gases. So in the sense that increase in pressure equals to what? Fewer moles of gas. Very important. Or fewer moles of what? Of gases. Very important. It's very important here. Remember, I told you that increase in pressure also is that what? Decrease in what? Volume. Decrease in what? In volume. Very, very important here. Now, another thing I want to pay close attention here is this. Another thing we want to take note here is this. Here we have a decrease in pressure of the gas. Right there. A decrease in pressure, which also says that what? Increase in what? Volume. We move the equilibrium position to the sides with higher moles of what? Gases. Very important. So whenever you decrease pressure, the equilibrium will shift to the side with what? Higher moles of what? Of gases. It means that decrease in pressure equals what? Higher moles of what? Higher moles of what? Of gases. Just now, what about in a situation where the moles are the same? So the moles of the reactant and the moles of the product are the same. So if you look at the mole of the reactant gases and the mole of the product gases, they are the same. Do you understand? So look at something here. Whenever the moles are the same, both the product and reactant, gases change the pressure and volume do not affect the equilibrium position. Just as this is what you want to put in your mind here. So whenever what? A reaction is having equal moles of gases, both the reactant and products, change in pressure and volume do not affect the equilibrium position. So these are three key things here. First one, second one, third one, I'll just say to you. There are three key things here you can use in what? Answer what? Some basic questions. Do you understand? So that is everything about what? Change your pressure and volume. So now let's start using this knowledge now to start tackling some what question like the one displayed on this board here. So let's get at what question one here. Which of the following equilibrium is shifted to the right as a result of an increase in what? Volume. So look at statement here. Increase in what? In volume. So whenever an increase in pressure, just an increase in pressure. So whenever a pressure increase, the reaction will move to the side with what? Fewer moles of gases. So you have to put that in your mind here. They say increase in pressure. Now whenever you increase pressure, the reaction will always move to the side with what? Fewer moles of what? Of gases. So now let's tackle this one here. Now if you look at the first one here, we have H2 gas plus I2 gas give you what? 2 hydrogen hydroxide H2 I2 hydrogen iodide. You get? Yes, hydrogen what? Iodide. I almost forget the name. So now here we have, if you look at the reactant side, here we have 1 mole of gas, 1 mole of gas. If I should sum them together, here we have 2 moles of gas here, 2 moles of what? Of gas. So because the reactant side, 1 mole, 1 mole, if you add it together, it's 2 moles of gas. Here we have what 2 moles of gas. Now, what I tell you when the moles are the same on equal side? I tell you that whenever the moles are the same, pressure and volume do not affect the equilibrium of position. So this one, pressure and volume is not affected. So this one is wrong here. There's no effect here. Just so let's look at this one here. Here we have 2 moles, here we have 1 mole. Right there. So here we have 2 moles, here we have 1 moles. Now remember, they're talking about increase in pressure. An increase in pressure will cause the reaction equilibrium to move to the side with fewer moles of gases. Now this guy is on the what? Is on the product side, right? So the reaction will move to the what? To the product side. Why is the reaction move to the product side? Because the product side have lesser or fewer moles of gases compared to the reactant side. So an increase in pressure will favor the side that have what fewer moles of what of gases. And this will have to be the one that have fewer moles of what of gases. Just that. So the reaction will move to the what? The reaction will move to the product side, which will what to the right. So this will what move to the right. Right there. This is which of the following equilibrium is shifted to the right as a result of what an increase in what pressure. This one happen to be the what the correct option. But now let's look at this other point here. Let's look at this other point, right? If you look at this one here, at C, now here we have 1 mole, right? Then the right hand side is having 1 mole. The product side is having 1. So 1 plus 1 is 2. So here we have 2 moles. Here we have what 1 moles. Right there. Of course, this one will shift to the what? To the left. We shift over to the left. Because we have what called the right and we have what called the what left. So we should shift over to the left. Which is wrong. Do you understand? The same thing here. Here we have 2 moles, here we have 3 moles. The reaction will shift to the left, which will to the product side. So here we have left. So you can see that the option here is what? Is B. So that is why you need to understand the concept very well enough for you to be able to answer some critical questions. Let's move to what next question. So let's look at what these 2 questions under what change the pressure and what volume. So please pay close attention here. And that is why here we'll be moving to exam possible question or exam style question. So in that one there, you're not going to focus on change the concentration, change the temperature, and change the what in pressure. Then you have to look at other ways they ask question in the exam. So please pay close attention here. So so that which of the following equilibrium shows lead to or no net reaction when volume of system is decreased? You understand? So now when the volume did not show, when the reaction did not show net reaction, you understand? When volume is decreased, so it means that the moles are the same, the more of the gases are the same. So when equilibrium do not show any sign at all, you get when equilibrium state did not show any sign at all or no net reaction, when either pressure or volume is being increased or decreased, that is the reaction have what equal moles of gases. You get. So the answer is going to be the one that have what equal what moles of gases. Both the reactant and product. That's going to be the answer. So you have to pay close attention here. So when I say no net reaction, no net reaction, when there's when volume of pressure is being decreased, that is the moles of the reactant and product are the same. That is what means. So let's look at it very well. H2 is gas, H is gas, hydrogen iodide is what is gas. How many moles do you have here on the reactant side? 1 plus 1 is 2. Yes, 2. So of course this is the correct answer. You get it. This is what the correct answer. So question like this, see question like this in your exam, it should not take you up to like 3 seconds or 5 let me say 20 seconds. You should be able to answer it. That's why it is very, very good. If you really want to blast your JAMB examination, you need to cover this topic very, very well. Now, each of these topics you must cover them very well. So that is why you want to always check out our class, because we upload twice on a constant basis till you have to write your exam. Yes, so that's why if you have not subscribed to the channel, please endeavor you subscribe to this channel. Share this video to your other colleagues or friends that will be writing what JAMB this year, so they took our join class. And another thing here is that we want to grow our subscriber to about 5,000 subscribers in the next few weeks. So please kindly help us to subscribe so you can meet our target. So, but now let's look at this one here. Yeah, how many moles of gas do you have here? Here we have 2 moles of gas. Here we have what mole of gas. Right there. So there will be an effect here because an increase in pressure will cause the reaction to move towards the product side, right? A decrease in pressure will cause the what move to the what to the reactant side. Do you understand? So what about here? Here we have 1 mole, here we have 2 moles. Right there. Here we have what? Here we have 1 mole, here we have what? 2 moles. So is change in pressure will affect this because we have what different moles of gases. Now look at this guy here. Now here we have, remember we are looking at gases. So we are not looking at this guy, we are looking at what this guy. So here we have gas here. So of course this guy have higher gas than that one here. We don't have 1 mole of gas, so do not have any gas at all. So change in change in volume or change in pressure will affect this one here. So the option is going to be this one here because they have equal moles of gases, 2 moles here, 2 moles here. Do you understand? Easy as that. Now the next thing you want to look at is what is this one here. Look at this reaction here. In this reaction above, an increase in pressure will, look at something here. How will increase the pressure affect the equilibrium position of this one here? Will it shift to the right or will it shift to the left, or there will be no net change? Now this is where you need to pay close attention here. Remember, pressure and volume only affect gases, so it does not have effect on liquid and solid. You get? So our attention, we are not going to pay attention to this guy because it's solid. We are not going to pay attention to this guy here because it's what is solid. Right there. Our attention is going to be on this guy and what and this one here. Do you get that? So here we have 4 moles of gas on the reactant side, 4 moles of gas on the what on the product side. And some of you will say, why is water gas? Yeah, that is what some of you be asking. Now remember, water is the only molecule that can exist in 3 states: as solid, liquid, and gas. So you sometimes can see it in solid state, sometimes you can see it in gaseous state, and sometimes you can see it in liquid or state. Yeah, is what is the gas state. You get? So yeah, how many moles do you have here? Here we have 4 moles. Here we have what 4 moles. So there will be no net reaction here. Over you increase volume, decrease volume, increase pressure, decrease pressure, there will be no net change. Do you understand? Because why? The two of them are what are the same. So they say that the reaction above an increase in pressure will, you say that favor the forward reaction. Of course, no. Favor the reverse reaction. No, does not have effect. Have no effect on the reaction. Correct. C is the what? C is the what is the option. It have no effect. Now, why does it not have any effect? Because the moles of gas on the reactant side and the moles of gas on the product side are what are the same. So they have no what effect on the reaction. So this is what the answer. So this is what we're going to give. Hope you understand. So now let's start looking at some technical questions, ways and patterns you see questions in the exam. We're going to be past question. Do you understand? So let's get into it. Now, before we end this class, let's look at some past questions. So we cannot do every past question here. Your own is to, now after you finish this video here, make sure you go to your past question and answer what more questions yourself so that you understand ways and patterns. Questions like this comes out in the exam. Do you understand? And the good thing is that if you're able to answer most of the questions, now I can guarantee you that 2 or 3 of the questions you have answered before, that what you're going to see in your exam. You get? So you want to pay close attention here. So now, if you have not watched the first video on chemical equilibrium, please make sure you check out the first video. That first video is very, very important. So let's look at what the first one here. They say that in the reaction, look at the reaction here. E plus F equals G plus H. The back of the reaction is favored if the constitution is. Now, how does change in constitution affect the equilibrium position? You get? Now, from the first video, I said that an increase in concentration at one point will cause the reaction to move to the opposite side. Now, what do I mean? It means that if I should increase the concentration of the reactant, the equilibrium position will move to the product side. And likewise, if I should increase the concentration of the product, the reaction will move to the reactant side. Do you understand? So the same here, a decrease in concentration of the reactant, so a decrease in concentration at one point will cause the reaction to move to the same side. Now, what does that tell you? It tells you that when you decrease the reactant, when you decrease the reactant concentration, the reaction will move back to the reactant. And when you decrease products, the reaction will move towards the product side. So we don't understand let's look at this question here. They say that the backward reaction is favored if the concentration. So how does the backward reaction favored? So how do you favor backward reaction? Just now, how do you make the reaction to move backwards? Now there are two things you can do here. Now you can either what decrease the reactant. Do you understand? You can either decrease one of the reactants. Do you understand? So for the reaction to what move backwards, there are two things you can do here. Now, is it that what you decrease the reactants? Because a decrease in the reaction at one point will cause the reaction to what move to the same side, either or to the same point. So instead that when you decrease the reactants, the reaction will move to the reactant side, which called backward reaction. If you don't want to use that one there, now another one you can use there. Remember, an increase in concentration at one point will cause the reaction to move to the opposite side. It means that if she increase the product side, the reaction will move backwards. So for this reaction to occur here, for this reaction to shift back, is that what you decrease the reactant or what you increase what product? So let's look at what the option E. So remember, I'm looking at this. So sorry, remember, I'm looking at this one here. So E is reduced. E is reduced. So we affect one here because if I should reduce E, it will move backward. Do you understand? So I will affect one as one of the correct one. Do you understand? G is reduced. G is what? G is what? Is a product. So if you reduce G, you have reduced what the product. So it will move to the right hand side or forward. Do you understand? So this one is out of it. F is increased. Look at something here. If she increase this one here, remember F is a reactant, right? If she increase F, it will move to the right hand side. Do you understand? So this one is not the answer. E is increased. No. E is what is. If she increase E, remember E is a reactant, right? So if she increase E, it will move to the right hand side, which will move to forward, which will move to forward the reaction. So this one is what is wrong. So the only option that is right here is what E is what is reduced. This is what is the right one. E is what is reduced. So when you reduce E, what happens here? It moves to the move backward the reaction. Do you understand? Now let's move to question 2. So you can see how trickish and technical this question look like. So if you don't fully understand the concept, there's no way on earth you'll be able to get the answer because the question will look so confusing. So the next thing, let's look at our question 2. 3H2 plus N2 give you what ammonia here. You have negative is negative. Now remember, when a reaction is negative, you are talking about when a reaction has delta H to be negative. We are talking about what exothermic reaction. Do you understand? We are talking about exothermic reaction. Now, what do you understand by exothermic? Now, when the reaction is exothermic, what do you understand? Exothermic means what? It lost what it. So whenever it is lost, it's called exothermic reaction. And in exothermic reaction, it is treated as what as a product. So in the sense that is why I need to check out my test here. So in the sense that it will be treated as product. So if you should rewrite this one here, we have 3H2 gas plus N2 gas. Here we have what 2NH3 plus what temperature. You understand? So because it's exothermic here, it will be treated as what as product. So here you can either increase it or decrease it. You get? So when you increase temperature here, now you treat temperature as concentration, as what? As concentration. So when you increase temperature, the reaction will move backwards. Do you understand? When you decrease temperature, the reaction will move forward. You don't need to cram this here. You only need to understand the concept. The main reason why so many people don't actually understand chemistry is because they are trying to cram the concept. You don't need to cram the concept. You need to understand the concept so that whichever way they are going to ask the question, you already know this thing here. Just that. So this is what I normally tell my students: don't cram anything. Try to understand the concept because with the understanding of the concept, now no matter how the question will be twisted in the exam, you should know what the right answer. Do you understand? So because here we have is the it will treat as product here. So when you increase temperature, it will move to the move backward. When you reduce it, it will move forward. So it's that the reaction above in the reaction above, lowering of the temperature, that is when you decrease temperature. What will happen when you now decrease temperature? Now, what will happen when you decrease temperature is that it will move to the product side. Idea. So let's look at this here. Have no effect on the equilibrium position. No, this is not the answer. Just increase the rate of both the forward and reverse reaction. No, this is not the answer here. Favor the forward reaction, of course. Now it's going to favor the forward reaction. Why? Because when you reduce temperature, it will move forward. So this is the correct answer here. Favor the reverse reaction. No, this is not the answer here. So you need to be more sensitive. That's why you need to master this here. So like what I say, if you have not covered your chemical equilibrium, please try as much as possible to cover that topic very well. It's very important. Now let's look at what question 3 and question 4. Question 3 and question 4 not give us tough time. So you see that for a reaction to attain chemical equilibrium, it must, look at something here, it must be a reversible reaction. For a reaction to attain equilibrium position, that is, there must be a reversible reaction. So what is a reversible reaction? A reversible reaction is a type of reaction in which what, as the reactant are reacting to produce products, the product also reacting back to what produces what the reactant. It's called reversible reaction. So if you now get to a point or a temperature where the rate at which the reactant is producing the product is also the same rate at which the product is also reacting back to produce the reactant. So for equilibrium reaction to occur, it must be at equilibrium. It must be a reversible reaction. That is it. Now look at this other one here. They say that, look at this reaction here. They say the reaction above can only attain equilibrium if. Now, how will this one attain equilibrium? Right there, it is a closed system. It's an open system. One of the products is removed. A gaseous reactant is added. Now the answer is what? A reversible reaction will always take place. Or yes, a reaction can only attain equilibrium in a system, in a what? Closed system. In a closed system. Because if it's not a closed system, if it's an open system, as the reactant is reacting, is what? Losing. Right there. But it is a closed system. What will happen here? It cannot escape. Because it cannot escape. Now because the product cannot escape, it also reacts back to form the reactant. So for a reaction to attain equilibrium, it must be what we close system. So we have come to the end of this class. Thanks for watching. Please, if you have not subscribed to the channel, please kindly subscribe to the channel. We have more videos here. Now, gas is for those of you who are also having issue with gases. Please go and check out my video on gases. It will be displayed on the screen. See you.